welcome all to this session, which is going to explain the motion of a projectile. So this is the objectives of this session, which are basically the kinematic relation of a projectile motion in horizontal direction, vertical direction, and we will also talk about the rule of acceleration. Two definitions. First, we want to define what a projectile means, the word projectile, and what is the meaning of a trajectory. So, a projectile is anybody that is given an initial velocity, and the word initial velocity is very important. And then follows a path determined by the effect of a gravitational acceleration and air resistance. So again, the body will be kicked with an initial velocity, and then it will just fall under the gravitational acceleration, under the effect of gravitational acceleration and air resistance. Now, what is a trajectory? A trajectory is the path followed by a projectile. Now, here is a simple experiment that explains a very important basic concept for a projectile. And basically, what we see over here is a ball which was given an initial velocity, and then the ball was moving in a projectile. That's the path as we described. Now, if we record this motion like this and then construct those lines, the vertical and horizontal line, we will observe something very important, which is this. The interval or the distance between the horizontal line are identical. Those distances are identical, while the distances between the two vertical lines are not the same. They are actually getting bigger, which means that the motion in the horizontal direction is uniform. It's always having the same magnitude, and that the motion in the horizontal direction is not affected by the vertical direction. This is again another way to explain the previous concept. So the horizontal and vertical components of the velocity are independent. They don't influence each other. And then if we look at the vertical component, which is the y component, in this example over here, we have a projectile which was given an initial velocity. The projectile is right here, and it was given an initial velocity v0 at an angle theta 0. Now, all what I want you to focus on is the length of the vectors, where we start with the length of this vector v, y, 0. And what we see is that this length starts to get smaller or shorter until it vanishes right here. So in this portion of the motion, we are actually acting against the gravity. And for that, we are losing speed until we stop momentarily in terms of the vertical component. But in the second portion, we see that the arrow start to get bigger, or its length start to become more. And in that sense, we are actually gaining speed because we are moving in the direction of the acceleration of the gravity. Now, if you, on the other hand, look at the x component, the length of the vector is always the same, which is again the same concept that we discussed in the previous slide. So let's look at the next slide where we show this mathematically. So if the horizontal motion is uniform, then the velocity in the x direction is constant. This is why we cover same interval with time. And if the velocity is constant, then the acceleration in the x direction is going to be 0. So we now write the constant acceleration relation as follows. So if you remember, this is the first equation, v equals to v0 plus ac t. And if we want to write this one in particular for the horizontal motion of a projectile, this equation is going to be vx is equal to v0x. There's no other part. The part which is ac multiplied by t is gone 0 because the acceleration is 0. Now we write down the second equation. Again, we take the right hand side as positive and we say v squared is equal to v0 squared plus 2ac multiplied by s minus s0, and the equation again will be vx equals to v0x. Why? Because this part is multiplied by ac, which is 0. So we left only with this part. We go to the third equation again, which is x equals to x0 plus v0 t plus half ac t squared. And for this, what we are going to get, x equals to x0 plus v0 x multiplied by t. Again, the same reason, this part is gone because the acceleration is 0. So what we are getting over here is this. We're saying that horizontal velocity remains constant. How did we get this? We get it from these two equations. This is a result of these two equations. It's always the same. And we get from the second equation right here, we get another conclusion, which is that equal distance covered in equal time interval. And this is written as Vx equals to x minus x0 over t. Now, if we talk about the vertical motion, the acceleration is indeed the gravitational acceleration. And because the gravitational acceleration is acting downward, then it is basically considered to be negative, and its magnitude, it's 9.81 meter per second square, or 32.2 feet per second square. Now, we write down the constant acceleration relations again, and for that, we will have upward as positive. The first equation, v equals to v0 plus ac multiplied by t. So if we rewrite it for vertical motion of a projectile, we will get vy equals to v0y minus gt. Then we replace the acceleration over here with minus g. We write down the second equation now, which is y equals to y0 plus v0t plus half ac t squared. And if we rewrite it, it's going to be y0, it's going to be y equals to y0 plus v0 yt minus half g t squared. The last equation is v squared equals to v0 square plus 2ac multiplied by s minus s0, and this is going to be vy square, which is equals to v0 y square minus 2g multiplied by y minus y0. So what we get is that equal increment of speed gained in equal increment of time, and distance increases in each time interval. And that explains the ball motion on the previous slides that I showed you. So if we deal with a projectile motion, we have two assumptions: is that this is a free fall acceleration under the effect of gravitational acceleration, and we neglect the air resistance. We choose y direction as positive in the upward direction, and we of course we will have ax equals to 0 and ay equals to minus g, and we usually take x0 equals to y0, which is equals to 0 at time equals to 0. Now, when a projectile is fired, it will move up until a certain point, after which it will start falling down. This point is the maximum height the projectile can achieve, and we want to know how to calculate this height. Now, we start with this equation, Vy equals to V0y minus gt. Now, we know that a projectile, when it reaches the maximum height, its vertical component, Vy, is 0. So, this one is equals to 0. So, when we equate this with 0, we will get an expression of time. This time we call it T1, and it's basically the time to reach the peak. This T1 is equal to V0y divided by g. From where we get this? As I said, we got it by equating this relation to 0. Now, if we want to find the expression for h, we need to have another equation. So we're gonna use the other equation, which says y is equals to y0 plus v0 y t minus half gt squared. Now, if you look carefully over here, what we said in the previous slide is that we will always take this position as the reference, and we will assume that y0 equals to x0, which is equals to 0 at time t equals to 0, which means that this one is equals to 0. Now, all what I can do here is to substitute T1 in here. And what I would get y equals to v0y squared over g minus half g multiplied by v0y over g all squared. And if I take the common factor, I will end up with h, which is equals to y max, which is equal to v0y squared over g, and multiplied by 2. And this is the expression of the maximum height achieved by a projectile. Now, if we have a projectile which is fired with the same velocity but different angles, which we call the projection angle, then the question is, when are we going to achieve the maximum height, as shown over here? For example, the maximum distance is covered by an angle 45. So if we shoot at angle 45, we will cover the maximum distance, which is the range. But if we want to reach the maximum height, then we would have to shoot at angle 90. So let's have this example. So a ball is given an initial velocity of v0 equals to 37 meters per second at an angle of theta equals to 53.1 degrees. We want to find the position of the ball and the magnitude and the direction of its velocity when time equals to 2 seconds. We want to find the time when the ball reaches the highest point of its flight, and we want to find the height at that point, which is the maximum height. Also, we want to find the horizontal range, which is the x distance which is covered by the projectile when the ball hits the ground. So we start with calculating the initial velocities of the ball, which are like this. So v0x is equal to v0 cosine theta, which is 37 meters per second multiplied by cosine 53.1, which is equal to 22.2 meters per second. We can also find v0y, which is equals to v0 sine theta, and this is basically 37 multiplied by this has to be 37 by sine 53.1 degrees, and this is going to give you 29.6 meters per second. Next, we calculate the position, and for that we need to find the x component and the y component. For the x component, we have one equation, which is v0x multiplied by the time. So we just calculated v0x, which was 22.2 meters per second, and the time was given to us 2 seconds, so we get 44.4 meters. Now, for the y component, we have v0y t minus half gt squared. Please note that there is a y0 here, which is equals to 0. So, to calculate this, we get the v0y, which was 29.6 multiplied by 2 seconds, and then minus half by 9.81 multiplied by 2 seconds square, and for this we will get 39.6 meters. To calculate the velocity, we have Vx equals to V0x, it will not change, which is equals to 22.2 meter per second. For the Vy, it is equals to V0y minus gt, and this one is 29.6 minus 9.81 multiplied by 2 seconds, and this is going to give you 10 meter per second. So if we want to find the magnitude, we square the component under the square root, so we have 22.2 square plus 10 square, and what we will get is 24.3 meter per second. To find the direction, theta is the tan inverse of 10, the y component divided by the x component, which is 22.2 meter per second, and this is going to give you 24.2 degrees. Now we want to find the time when the ball reaches the highest point of its flight, and we want to find the height at that point. So if you remember, we already did this by saying that Vy, which is equals to 0, is equal to V0y minus gt1. We call t1 is the time to reach the maximum or the peak, which is equals to V0y divided by g. So in that sense, what we are going to do is divide 29.6 divided by 9.81. This is going to give you nearly 3.02 seconds. Now, to find the maximum height, we have h, which is equal to V0y multiplied by t1 minus half gt1 square. Now, just focus with me. Here, the height is actually y, and there we have y0, which is equals to 0. So if you use this equation, you will see that this height is 29.6 multiplied by 3.02, the time one, minus 1 over 2, 9.81, multiplied by 3.02 square. And this is going to give you 44.7 meter. Alternatively, you can use the equation y max, which is equal to V0y square divided by 2g, if you remember. And if you substitute, you will have 29.6 squared divided by 2 multiplied by 9.81, and this is going to give you almost an identical answer. The last part of this question is to find the horizontal range, which is the horizontal distance from the starting point to the point at which the ball hits the ground. Now, for this one, what we are going to do, we are going to write down the equation y equals to y0 plus v0yt minus half gt square. But what we are going to do, now we know that y1 is equals to 0. We know that. But what we also know is that since the projectile started from this point, it went up and then it moved down. So this is the location of y0, this is the location of y. So we also going to say that y is equals to 0. And to distinguish the time to reach point H, which is the maximum height, which we call T1, we are going to call the time which is from here all the way to there, time 2. For that, we are going to have this equation now. So we will have V0 y T2 minus half G T2 square equals to 0. So if we take T as a common factor, we will have T2 multiplied by V0 y minus half G T2, which is equals to 0. So we get the trivial solution, T2 equals to 0, or T2, which is equal to 2V0y divided by G. If we substitute this, which is 2 multiplied by 29.6 divided by 9.81, we will get 6.04 second. This is twice as T1 because the motion here is symmetric. Half of the time is spent from this point to this point, and then the next half is spent from this point to point. And again, this is only because the motion is symmetric. So if we do this now, we can find the range, which is actually x, using the simple equation V0 x multiplied by t, because V0 x is 22.2 multiplied by t2. Be careful. So here the time is going to be 6.04, and this is going to give you 134 meter. To summarize, we defined projectile trajectory. We also talked about a free fall under the effect of a gravitational acceleration and the projection angle. We described the motion of the horizontal in the horizontal direction, in the vertical direction, and we said that there is no acceleration in the horizontal direction, while the acceleration in the vertical direction is minus g. We also talked about the projection angle and what is the angle that enables us to achieve a maximum range or a maximum height. We expressed the equation of maximum height h or y max, and also we talked about how to find the range. Thanks a lot.